Hi everybody. So in this video, we're going to look at tree diagrams for independent events. We'll work through two examples and then we'll try some exam style questions. And if you want to work along with me, you can download a copy of this PDF from my website. I'll leave a link below. So in our first example, we're told that Eliza has two fair spinners. Spinner A is 5-sided and numbered 1 to 5, and spinner B is 9-sided and numbered with numbers given here. We're told that Eliza spins for two spinners and records whether they land on a prime number, and then we've been asked to complete the tree diagram. So to complete the tree diagram, we start at this point, and then we either spin a prime or a not prime. You can see there's three numbers that are prime, the 2, the 3, and the 5. So there will be two numbers which are not prime. So this is 2/5. And you can see this works because the prime and not prime are both mutually exclusive, so the two probabilities must add up to 1. And then it doesn't matter whatever we get on spinner A, this has no effect on the separate spinner, spinner B, because these two events are independent. So spinner B, to get a prime, you can get these 3s or these 5s. So there's 5 primes out of 9 in total, which means there will be 4 which are not prime. And again, they're mutually exclusive, so they should add up to 1, which they do. And it doesn't matter if you get a prime here or not prime, you'll get the same probabilities if you got a not prime on spinner A. So that's our tree diagram. And then we're asked to find the probability that the two numbers are both prime when we spin them. So you start at this point, we want a prime on spinner A and then a prime on spinner B. And in probability, the word and means multiply. So we want a 3/5 multiplied by the 5/9. So for part B, the probability of a prime on spinner A followed by a prime on spinner B will be the 3/5 multiplied by the 5/9. And we can work this out. We've got 3 times 5, which is 15, and then the 5 times 9, which is 45. And we can simplify this fraction to make 1/3. Okay? And then for part C, find the probability that the two numbers are not both prime. So this means we can have a prime and a not prime. So a prime on A and a not prime on B, which is this path. Or we could get, and the word or means add, or we could get a not prime followed by a prime. And this is this path, not prime on A and a prime on B. Or we could get a not prime followed by another not prime. And this would be this path and not prime. So you can see there's 3 possible outcomes here. Now we could work out the sum of all of these 3, but it's much easier to consider a prime followed by another prime, which we've already worked out as 1/3. Because it is certain you'll get one of these 4 outcomes. And this will be the same as 1, which means certain, minus the probability of a prime and a prime. So 1 minus 1/3. And this will give us 2/3. Okay? Let's try another question. So in our second question, we're told that a bag contains 15 red beads and 10 blue beads. Daniel picks a bead at random, records its colour, and replaces it in the bag. He then picks another bead at random, and because he replaces the first bead back in the bag, the two events are independent. We've been asked to complete the tree diagram. So do you want to try this question yourself? Okay, so how did you get on? Well, if there's 15 red and 10 blue, there's 25 in total, with 15 of them being red. And we can simplify this fraction. We can divide both by 5, and we get 3/5, which means the probability of a blue would be 2/5. Because it's mutually exclusive, you'll get a red or a blue. And we can see that this 10 over the 25 does simplify to make 2/5. Okay? So I'll just rub this one out. And then because the first bead is being replaced, we'll have the same probabilities for the second selection. That's part A. For part B, find the probability that it picks 2 red beads. So the probability of a red followed by another red. So if we identify that path, red followed by another red. So this will be 3/5 and, which means multiplied by another 3/5, which is 9 over 25. Okay. For part C, find the probability that it does not pick 2 red beads. So this means you could pick 1 red bead or 0 red beads. So we're looking at the probability of a red and a blue, or a blue and a red, or a blue and a blue. So if we identify these paths, a red and a blue, or a blue and a red, or a blue and a blue, and you can see there's 3 possible combinations, and all 4 combinations will add up to make 1. So it's easier to have 1 subtract the probability of a red and a red, which we've already worked out here. So this will be 1 minus 9/25, which gives us 16/25. Okay? Let's try an exam style question. So in this question, we're told that Claire and Sarah each take a test. The probability that Claire passes is 0.8, and the probability that Sarah passes is 0.4. We've been asked to complete the tree diagram and then to work out the probability that they both pass. So do you want to try this question yourself? Okay, so welcome back. So it's mutually exclusive whether Claire will pass or not pass. So this would be 0.2. And then for Sarah, we're told that she passes is 0.4. So her not passing will be 0.6. And it's independent of Claire's performance. So this will be the same probabilities, 0.4 and 0.6. Then we want the probability that they both pass. So this would be a pass followed by another pass. So we're looking at 0.8 multiplied by 0.4, which will give us 0.32. Okay, let's try another question. So in this question, we're told that spinner A and spinner B are each spun once. The probability that spinner A lands on a red is 1/4, and that the probability that both spinner A and B land on a red is 1/24. We've been asked to work out the probability that exactly one spinner lands on a red. So do you want to try this question yourself? Okay, so if we begin with our tree diagram, we can get a red or a not red. And this will be on both branches, a red and a not red. Now we're told that the probability of spinner A, we'll label this one A and this one B. Getting a red on A is 1/4. So a probability of not getting an A must be 3/4. And then we're told that the probability of the spinner A and B being red is 1 over 24. So if we identify that path, it'll be red, and this will be 1 over 24. So the probability of a red on A multiplied by the probability of a red on B will equal 1 over 24. And we're told that this one is 1/4. So 1/4 times the probability of a red on B will be 1 over 24. We can divide both sides by the quarter. So the probability of a red on B will be 1 over 24 divided by 1/4, which is 1 over 6. Okay? So we can label this on our tree diagram, which means not getting a red would be 5/6, and it'll be the same in the other branch. So then the probability that exactly one spinner lands on a red, if I erase these, well, that'll be a red and a not red, or a not red and a red. So this will be 1/4 times 5/6. So 5 over 24, or 3/4 multiplied by 1/6, which is 3 over 24. So the probability of a red and a blue, or a blue and a red, will be 5 over 24 plus 3 over 24, which is 8 over 24, or 1/3. Okay? Let's try one final question. So finally, we're told that Liam has a biased coin. He spins the coin 3 times, and the probability that the coin lands on a head 3 times is 27 over 64. We've been asked to work out the probability that the coin will land on a tail 3 times. So do you want to try this final question yourself? Okay, so if we begin at this point, we can either get a head or a tail, and we're told that he gets a head. So I'll label this as a head. And then on the second go, he gets another head. And then on the third go, he gets a head again. And because it's the same coin, and the 3 events will be independent, these will be the same probabilities. So if we label this as x, then x to the power of 3, when you multiply this by itself 3 times, will give us 27 over 64. So we can work out x as the cube root of 27 over 64. And this will give us 3 over 4. So the probability of getting a head is 3/4. The probability of getting a tail must be 1/4. And we want to work out the tail 3 consecutive times. So this will be a tail, another tail, and another tail. So the probability of 3 consecutive tails will be 1/4 multiplied by itself 3 times, and this will give you 1 over 64. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and the PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link below.